Hey, welcome to another edition of Office Hours. My name is Sohan Maheshwar. I'm a dev advocate at AuthZed. For those of you all joining for the first time, we do this once every fortnight or so, where we take something cool that we're building on and we'd love to share it with you. And today we're going to be talking about building infrastructure on the hyperscalers. So I have Brad and Adine. Brad, Adine, first time on Office Hours. Welcome to the show.
Thank you.
So Brad and Nadine work at the SRE team here at AuthZed, and they've spent a lot of time and they have so much expertise building infra on the cloud, specifically on Azure, AWS, and GCP. So we thought we'll take some of those learnings and share it with y'all. And again, this is Office Hours format, so if you have any questions, feel free to put it in the chat or just say hi and tell us where you're watching this from. Brad, Adine, so we've built AuthZed to be able to run on these different hyperscalers. Maybe give us a two-line introduction on what AuthZed Dedicated is, Adine.
AuthZed Dedicated is our cloud offering where we pretty much manage a SpiceDB instance for you. Brad will shortly demo the AuthZed management dashboard, which is a web-based application for organizations to manage SpiceDB deployments. And the management dashboard is exclusive to AuthZed Dedicated and soon AuthZed Cloud. Brad, take it away.
Cool. Yeah, so I can do a quick demo here, and just to add to that a bit, this is our cloud managed platform for SpiceDB. You can think of it similar to like RDS exists for things like MySQL or Postgres, or there are other platforms. CockroachDB has their Cockroach Cloud. This is our version of that, right? Where we give you a management console, and you can spin up SpiceDB clusters and manage them and scale them on your own, and then we kind of handle all of the automation and the day-to-day management on the back end ourselves. This is like I'll do a super quick demo here. I won't go into really interacting with SpiceDB or whatever, but just to kind of show the management UI. Maybe that's also a good point, just to time to mention that, to kind of describe a little bit more about like what we've built, is that AuthZed Dedicated in particular is a fully isolated single tenant environment. So every user gets like a full copy of the infrastructure. Their control plane belongs only to them. Of course, like always, their data plane where their SpiceDB actually runs is fully isolated. And we'll get into this later, right? But that goes all the way down to the kind of like AWS account or GCP project or whatever layer, right? There's like nothing shared. It's all private to a single tenant. So here's the dashboard. Like I said, just a super quick demo. So this is where you'll see permission systems appears that we're in the default organization. So if I click on one, this is one called Thumper. So Thumper is our open source kind of load generator for SpiceDB. Everything is Dune themed. And so this is a permission system that we have running on our kind of demo cluster. And we're running Thumper against it to generate some traffic and just kind of see how things are working. So you can see there, you get this overview of deployments. So we have one deployment running in US East 1 here on AWS with some details about the compute that's dedicated to it and latencies and whatever. You could edit this and scale that up. So we could go all the way down from like a development permission system at 250 millicores all the way up to a 32 core gigantic machine, and the number of replicas and everything. And then, so there's other stuff here, like we have metrics. You can click through and see your throughput by the type of operation that you're doing or the consistency that you're requesting. Things like latency on those. So we can see here that the check permission latency here is pretty low. It's like 11 milliseconds, 14 milliseconds. Stuff like setting up audit logging. Access is for our internal fine-grained permissions dedicated to this SpiceDB, right? So you can set up different service account roles and tokens and the permissions they have and that kind of thing. And that's kind of it. So we can show, here's a demo of Materialize. Materialize is our product that does kind of materialize views on top of SpiceDB. So within SpiceDB, right, you might have a ton of data and a complicated schema, and some of the relations might be super wide, right? They might be huge. You might have groups that have billions of members, and they have other groups as members that have more members or whatever. Traversing all that data can be slow sometimes if it's really huge. And so Materialize will you can give it permissions to watch, and it will sort of materialize those and cache that, and then you can answer questions about those things much quicker. And so you can also manage that a bit here in the UI. So you can see like these are the different materialized caches that we've enabled and which permissions they watch, info on the jobs about the last time there was a snapshot of the data and that kind of thing. Yeah, and other than that, this is what it looks like to create a permission system. You can choose production or development, give it a name, choose CockroachDB channels. We have update channels, so you can kind of choose the cadence at which you get updates to SpiceDB, either rapidly, basically as soon as they're released, or you can choose the regular channel, which lags behind a version or two. It's kind of similar to the release channels in GKE, if you've ever seen that. Yeah, and that's it. So I can choose what size instance I want, which region, all that stuff, and save it. And it will go. And that takes a minute to spin up. But yeah, that's it. That's the basic demo of the management UI.
Yeah. Nice. So we wanted to set. Go ahead, Adin, please.
Sorry, I just want that. This is for platform operators that want to manage and configure the service through the UI, but we also have an API and a Terraform provider. So there's also infrastructure as code options.
Yeah, and thanks for the shout out, Adin, because next week at the same time, we're doing a live stream with Veronica from our team who built the Terraform provider. So she'll talk through a bit of that. But getting back to this, so the reason we showed you this demo is this is AuthZed Dedicated, which can run on the different hyperscalers. So we'll focus the rest of the conversation on the quirks, the differences, the similarities between these three hyperscalers, right? Building this. And yeah, let's start with, I think, maybe something that's probably the most similar, because SpiceDB is very cloud native and Kubernetes first. So both of y'all have a lot of experience working with the managed Kubernetes services across the three, right? So maybe we can talk through that to begin with.
Sure. So yeah, I think that's a good place to start, because like you said, that's maybe the most similar thing in a way. There's also differences that we can talk about, but across the major cloud providers. But that's also by design, right? And that's also why we use Kubernetes, is that it provides us this kind of API that's the same, even if there are some quirks that you have to work around, right? But like it provides an API across the different providers that we can write our higher level automation against. And so that's really like been our, I think, secret sauce to build out a platform like this as a fairly small company. So that's another point, right? That like half of the company came from CoreOS and Red Hat previously, working on CoreOS Tectonic, which is their Kubernetes distribution, and then OpenShift at Red Hat. And kind of a lot of us were there as the kind of operator pattern on top of Kubernetes was pioneered a bit, right? And so we lead on that super heavily. That's allows us to have an API to write this kind of like deployment and management operation against, that works the same, or that we can make work the same across the different cloud providers. So that's like a huge part of the foundational part of the platform that we built.
Yeah, it comes much to use. Recently, let's say when we added Azure support for dedicated, then it's like how much of our existing AWS and GCP stacks and approaches can we reuse and apply to Azure, and what do we actually have to develop and deploy individually for Azure that comes from IAM and service accounts and so on. So K8s is very important there, just to kind of mimic between the cloud providers.
Yeah. So let's start maybe going into like each of them, right? So of course we have EKS on AWS, you have GKE on GCP, and AKS on Azure. So yeah, let's talk about each of them perhaps.
Sure. Yeah. So I think just like a kind of couple of things come to mind for me, at least, whenever I think about the differences. They're mostly pretty similar, and that's, like I said before, right? That's the point, is that you get Kubernetes and it's just Kubernetes and you have the same API everywhere kind of. But yeah, there's some differences. Like one thing with EKS that we found is that we want to, of course, stay up to date and stay on the latest version of Kubernetes to get security fixes, get new features, get whatever. And that's been fairly painful on EKS because the operation is pretty manual. Like you have to kind of go through and there's a whole procedure and a whole order of like, update your control plane first, and then your nodes, and then your add-ons. But you can only go 3 versions at a time, I think, before you're out of compatibility. So if you do get too far behind, then you have to make multiple jumps. And yeah, so we found that pretty painful. It's been kind of a time sink every time we have to do one of those. Even though we have pretty good automation for doing it, it's still across a big fleet of multiple clusters. It's a time sink, and you kind of have to, if something were to go wrong, you have to be ready to kind of pause that rollout and jump on it and whatever. And yeah, so I think that's a difference between that and GKE. I think, and Adine, this has been your experience too, right? And GKE is like, you select the same way as we built it this way for a reason in AuthZed Dedicated, where you select a release channel and then we just auto update you. We modeled that really, I think, on GKE because it's the same there. You choose a release channel and then they just upgrade you. And like, in my experience, it's always just worked.
Yeah, but to add to that, you have auto mode for EKS now, right? Which will solve these pain points for us. It's just not attractive due to the pricing point. I think it was released in December, and they will charge 12% on each instance you provision. So if you provision an $900 instance, you would pretty much have $100 of extra surcharges for provisioning that. And I think we've solved many of the other pain points, which is like Carpenter to have auto-scaling node pools, and all of that fairly works well. And when we kick off upgrade, kind of Carpenter rolls out the node upgrade as well. It's just the control plane that's a bit tricky. And I think GKE gives a full experience, and not just in terms of maintenance updates and so on. You have like managed from ETS, you have managed backups. Everything is kind of click, and you choose to have it, but it's also pricey, right? And for us, it's building our own cloud. That's kind of a big factor, like how much of our revenue can be actually going to the clouds. And for Azure, we've been fairly content. Like a nice piece was pretty much Carpenter. I don't know what Brad used, maybe Cluster Autoscaler before Carpenter, but Azure has built a Carpenter provider. Doesn't work as nicely as AWS, I would say. Node spins up a bit slower. Documentation is a bit worse. Options for images is also a bit worse, but it kind of does a job. And it's nice that we have Carpenter both for Azure and AWS. But for GKE, we use node auto provisioning, which is a bit different. It's based on cluster autoscaler, and I don't think it scales up nodes as quickly or compacts them as nicely.
Yeah, I think all of that's fair. And that brings up another good point, is that in kind of the differences between the providers and their managed Kubernetes offerings, is that, so we run this platform, right, where we have like a kind of fairly fixed control plane where we run stuff like the management UI and our operators and whatever. And then there's like the data plane, which is dynamic and needs to scale up or down depending on what the user is deploying in terms of SpiceDB clusters. And for that, like what we really would love to do is just say, the user wants a 3 replica SpiceDB cluster. So that's like 3 pods, right, with this much CPU and this much RAM. Just go and give me that. And so all of the cloud providers have kind of their own way of doing that. So on AWS, you have Fargate, and that's cool. Like you have like a node pool that you say, yeah, this is a Fargate node pool, and then it just will go and spin up the exact resources that you need to run those things and do it. And GKE has something similar that's autopilot, where it works exactly the same, like, well, not under the hood, but theoretically, right? You give it resources and it spins up whatever it needs to run that stuff. I actually don't know if Azure has something similar, but I assume so somewhere. But the issue is that then those things each become like at least in the details, they become very cloud vendor specific, right? So then like you want to use Kubernetes to give you the same experience across clouds, and then to use these cool features, then you can kind of like get locked into the individual cloud vendors thing for doing that. And it's also usually pricey, right? Like I forget, like, I don't want to say the wrong number, right? But for GKE, autopilot mode it adds a significant percentage onto every core that you're requesting. So
Yeah.
like Adine mentioned, when you're doing, this doesn't apply to everybody because every like cost and whatever scales differently for everybody's infrastructure. But if you're doing a product where you're building a platform that like we're selling management on top of infrastructure kind of, so then you do have to think about those like kind of unit costs of
right, because it adds up, right?
Yeah, totally, exactly. But yeah, just one other thing that feeds back into that Adine also mentioned is, so the solution that we found for that is mostly Carpenter, because it works on AWS and it works on Azure, and it lets us just kind of like, we have to think about how we fit resources into machines a bit, but it kind of does that magic thing for us where we just say, hey, we want this many cores and this much memory for this thing, go and create some instances that match that somehow. And it's been super, super solid. We've been using it since way before v1.0 days, and like it's been super cool. It's a super cool technology, and we're super happy to have it, I would say. And that's another pain point on GKE, is that they don't have a Carpenter provider. They do have a built-in thing called node auto provisioning that sort of does the same thing, but then you're back in that situation where two of the providers we can configure exactly the same and get the same result and whatever for the most part. And then on this third one, we don't have all the same options. So we have to kind of figure out like how to make it work the most similar as we can or whatever. And it doesn't always fit exactly.
Yeah, and It also always becomes like, even if you see that each cloud provider has the same feature, when you start going into the configuration parameters, they differ a lot. Like even for Carpenter between Azure and AWS, you can't specify the same options, right?
Yeah. Cool. That was super informative. Folks watching, again, if you have any questions, feel free to put it in the chat. For those of you all just joining in, we're talking through some of the learnings building AuthZed Dedicated across the different hyperscalers. We spoke about managed Kubernetes, which, as Brad and Adine said, a lot more similarities, but things have diverged in like different services. So let's talk a little bit about IAM, right? Identity and access management. Brad, I've definitely seen some of your frustrated Slack messages when dealing with some of this. So let's talk through, the differences in IAM across these three, perhaps.
Sure. Yeah, so I guess starting with AWS, like their IAM system is pretty simple and it works fine. I think the headaches there are mostly around like multi-account stuff. It's like you can authorize IAM bits in one account to go cross account, but it could get pretty complicated fairly quickly. Then other than that, it like, I don't know, I would say SSO setup kind of thing, like it works fine, but it's another thing where it's kind of per account. Although that's also a bit on us maybe, because you don't have to do single tenant accounts in AWS. Like there are other ways of doing isolation, but we've chosen that because it was fairly easy to get started with.
Yeah, and that's for our dedicated product. Cloud is a bit easier, but our dedicated product relies on strong isolation. So each customer gets their own dedicated AWS account. And I think it also becomes a tricky issue for developers, how they access each account, how they log into each account, how they can check resources, interact with the AWS console, and so on. You don't have similar issues with GCP because you just switch projects, right?
Yeah, GCP. I do like the way GCP is set up there in general. That like having a kind of organization, and then you have projects within that instead of different accounts. Like they're also isolated kind of the same way, but it's just a little easier to work with because, though it's a really good shout out, I think one of the reasons it's easier to work with, particularly from an IAM perspective, is because they're using Zanzibar or a Zanzibar-like system like SpiceDB on the thumbs down.
I didn't even move anything, and it just gave you a thumbs down. My bad, Brett. We'll blame Apple for that one. Yeah.
No, thumbs up. Yeah, because
Thumbs
they're
up, yeah.
using they're using like a Zanzibar like system like SpiceDB, so that you can do this kind of cross project resource based authorization really easily. So I can easily say, that for everybody in this group that I want them to have access to this resource in this project. Like it's much more flexible, right? And they also have a lot of cool tooling for being able to see what resources people have, or people or groups or service accounts or whatever have access to. So yeah, I think it's a cool experience.
I think Azure does it similarly. You have a single directory, then you just start adding subscriptions. Each subscription is, let's say, a separate AWS account would be the equivalent. And then users in our organization can have access to each subscription you give them access to, right? So it's very similar to GCP, and a nice user experience.
I'm still confused by Azure though. Like, I just don't know the terminology yet. I'm not. So Adine did all of the work for getting us onto Azure, so thanks for that. And I'm still like kind of catching up, and all of the. This is always the case when you start using a new platform, but all the terminology is different. So there's like you have a directory and a subscription and a tenant, and it's just like still unclear about what's what.
Yeah, this goes back to the case discussion where we kind of try to mimic as much as possible between each platform. But these things we need to, this is an AWS account. What is the equivalent in GCP? That's a project. Here we have a subscription in Azure, and here comes the overhead, right, of multi-cloud setups.
Yeah, because some things like this are features of the cloud itself, of the hyperscale itself. So there's no way of, like going around that. Yeah, absolutely. And is there some way that we have like maybe dealt with all of this, like, to automate it and to improve that process when, like working with different customers who might have like different cloud accounts and stuff?
Yeah, totally. I mean, I think we'll talk about this maybe a little bit more at the end, some of our ways of like handling generating config that is a little different between each provider or whatever. But in terms of our internal platform and tooling, we use Tailscale for a lot of that. And that's been like a huge, totally love that product and that technology. So we have an internal Tailnet, and we run Tailscale on every cluster, and we use that as the kind of default access point for when we have to go in and do any kind of troubleshooting or just day-to-day operation stuff. So we can connect to each cluster securely that way and become authenticated. And that works then the same across every provider, right? We don't have to like go and log into AWS or Azure or GCP and then connect to a cluster using some IAM account or whatever. We go through Tailscale and we get the API proxy to the Kubernetes cluster via that, and then we're authenticated and it's secure. And another cool thing that we do with that is just-in-time access, right? So like we're not sitting around everybody with admin access on the clusters or whatever. We can go in and say for the next 10 minutes on customer ABC, I would like to have kind of like support level access to this cluster so that I can, maybe see some logs or do whatever. And then that does the notification that has to be approved. And similar for like, if I really have to go and do some kind of a maintenance for a user or something, that I can request admin, but same thing, like it's time box, it's just in time, and it has to be approved. And we all see that in Slack and stuff. And yeah, so we built that out based on their kind of built-in Tailscale enterprise just-in-time access bits, and we've been super happy with it. It's a really cool way to manage a multi-platform thing.
Yeah, I think Brad has created a nice solution there with Tailscale for user access. We still maybe struggle with service access because that differs between clouds. You have workload identity for GCP, Azure AD workload identity, IRSA for AWS, and then let's say you want to deploy a service, external DNS or Loki, you will actually have 3 different setups for each of these, right? How they interact with S3 or how they interact with Cloud DNS. So we have some AM differences there. I think we also build operators. How do we communicate with K8s clusters, Cube login for Azure, the G-Cloud Auth plugin for GCP, and the IAM Authenticator for AWS. Yeah. And obviously image registries differ. That's also one thing, right? Because each cloud provider gets their own image registry. So both pushing and pulling images is different.
Yeah, that's totally fair. Though I also wonder if we should just use Quay or something and call it a day. You keep giving me thumbs down, man.
This is my bad. I need to turn this off. This is yeah. Wait, I'm
just
going to sit. There you go.
Yeah, there we go. All right, happy thumbs up. Hearts.
Yeah, this is Apple. My hands aren't even on screen, and yet I don't know. Anyway,
I turned that thing off immediately when they released that. I was like sitting in meetings, you kept getting speech bubbles and stuff.
Yeah, Brad, you were saying.
Yeah, just agreeing with Adine that that's very true. Like there are still all kinds of little IAM stuff with it for like having our components authenticate to different cloud services that we have to kind of manage between different clouds. And then on top of that, yeah, there's like a whole other thing of like service to service authentication, which Tailscale can also do, but is the kind of control plane side of that, like management part of it, is definitely not as advanced as a dedicated like service mesh product like Istio or Linkerd or something. So that's another piece.
Gotcha. Okay. All right. Yeah, folks joining in, we've been talking about building infra on the hyperscalers. We spoke about managed Kubernetes and IAM. We'll move on to something maybe a little more controversial, because I've definitely worked on some aspects of this in a past life, which is like the load balancing and networking among the three, right? And I say a little controversial because each of the hyperscalers have like a bunch of different load balancers, like your classic and your network and all of that, which again can get a bit gnarly if you're working across, all of them and so that. So again, y'all have a lot of experience working on this. So yeah, take it away.
Yeah. So AWS for me is like, the model's pretty simple. It's well understood. It works well. Their load balancing offerings are also easy to understand, I think, and in my experience, scale well and stuff. The only like real remark there is that it's very, and I think this is the big difference, right? Is that it's very regional, right? So you have like US East 1, and you have your VPC network there, and then you have US West 2 or whatever, and you have your VPC network there, and they're separate networks, and of course you can peer them and talk across them, but then you have to like do that and plan for it and plan the IP space and whatever. So it's very like, you can tell that it started regional and the like multi-region or cross-regional bits were added later.
Yeah. I can also add to that, when working on Azure, one thing I was looking for was kind of decouple the load balancers from the K8s clusters. And I think this is something that AWS provides very nicely. You can create the load balancer, then you have the AWS load balancer controller, which you can just attach, right, through custom resource definitions to these load balancer services. Azure works differently. You create a EKS cluster, you kind of get your you get a load balancer to it, and then you can only interact with it through K8 services. But this becomes tricky if you have to recreate the cluster. You kind of lose the load balancer. There's downtime. You can't kind of migrate between clusters. The same goes with private link services, right, which we offer to customers to have private networking. These are also annotations on the load balancer service. And same thing there, if you delete the cluster, right, you kind of lose the private link service and have to interact with the customer for a migration for that. I think the GCP part is something Brad has been working on mostly and built the GCP support. So maybe you can walk through that.
Yeah, for sure. So GCP is different in that VPC networks are global, which is cool, right? So there's like, you have one VPC network that's global, and you can have subnets in every region, and they can talk to each other and everything. So like, that part is cool and is way easier. The one thing that is definitely a pain, or I found a pain in GCP, is just the amount of load balancer offerings that they have. So I even tried to look at my old notes from this before the call to like remember, and I still came away confused, because there's like internal UDP TCP load balancers, there's internal HTTP like layer 7 load balancers, there's regional ones and global ones, and then there's like proxy load balancers versus ones that are actually doing like forwarding traffic to your instance and then getting like a reply back. And each one then in terms of how they operate with GKE together, there's like they can be VM kind of level. I forget the exact term that they use, but where you can only really route traffic to an instance, and then from there it might have to bounce via kube proxy or something to another node. Or you can do like the kind of container native ones, so like VM IP port. So some of them support that, which load balance directly to a pod IP. And that's how we have it working in other clouds, and it's kind of the container Kubernetes native way to do it. So we wanted to use that, but then you have to like see, okay, that works with this one, but not with this one. And then if I add a like forwarding rule for this IP to this one, and it's regional and not global, then I can't use this other feature. And I just like, I honestly wish I could talk about this in a more kind of like experienced, intelligent way, but I can't, because I don't remember it all, because it's too crazy, right?
So yeah, when you told me, I was like, I'm actually curious how many types of load balancers are there on GCP. So I pulled it up, and turns out on their web page they have like a flow chart for like actually choosing one. Because you were right, Brad. Like I think these are all the different options they have, which yes is quite a few. And and hey Akash, thanks for joining the stream. If you have any questions, feel free to put it in the chat. Yeah, thanks for joining. But yeah, Brad, you weren't kidding.
The pain point is here when you manage this with Pulumi or Terraform. Changing one option usually recreates the load balancer, so you actually don't want to go into that, right? Because that's downtime.
Totally. And that's another good point, is that so similar to Private Link in AWS, we use private, or we offer Private Service Connect for private connectivity in GCP. And that's like an entire other layer that changes how this flowchart works, right? Because then some of these work with Private Service Connect and some don't, and some work with it being global and some not, and whatever. So it's like this whole other explosion of options when you factor that in. That reminded me, though, when you mentioned Pulumi and Terraform, of another thing. You touched on this, but just like to, touch on it again. That is something that we do, well, not in Azure, but in the other two clouds that we do, is, and this is just kind of a pattern that I've used for a long time. It's not necessarily, but I find it nice, right? Is that we create for the kind of like main ingress points in the cluster, we create the load balancers via infrastructure as code separately from the clusters, so that their life cycle isn't tied to a single cluster. So then, if you want to, say, do a Kubernetes upgrade where instead of upgrading in place, you spin up a new cluster and shift traffic to it, you can kind of do that by creating a new one and attaching the same ingress points to the load balancer, and then detaching the old ones when you're ready to switch over, and that kind of thing. So we've done that for, at least in AWS and GCP, for some of our ingress bits, and it's worked well, because GCP and AWS both have support kind of Kubernetes controllers for doing this attaching automatically of the pod IPs to the of the ingress points to the load balancers, and so we were able to kind of decouple those things and still have it be automated well. And so again, Dean knows more about this than I do in terms of like how it works on Azure, but apparently that it doesn't work the same. You already talked about this, right? But we could not find a way to do that. We had to basically have Kubernetes create the load balancer.
Yeah, there's GitHub tickets that kind of follow and track these that are heavily uploaded. So we try to keep track of it if it's introduced differently. I mean, it's not just a nice thing have. We also want replication between the clouds. Now we kind of have to always remember that Azure works completely differently, right? But yeah, I think general experience with Azure was a lot of GitHub issue tracking for these things, and not a lot of responses. So
yeah, we have a comment from BDay38. First, BDay38, thanks for joining the stream. Said that's super clever. Well, thank you. But BDay38 also says I deploy SpiceDB with SST, which is pretty cool. I don't know if at least I have not come across in like our Discord and stuff someone deploying with SST. I'd love to hear more about your experience doing that, BDay38. That's cool. Oh, okay. Jimmy has something cool which says the AuthZed founders did Y Combinator with the founders of SST. So good. This is two universes colliding. But yeah, feel free to put that in the chat. I'd love to hear more about that, Vijay. And yeah. Okay, so let's move on from like the load balancing and networking bits to something I think a little more like operational, which which I know for a fact that when you're learning cloud for the first time and stuff, these are the things that you would gloss over for like the more cooler things. But when you're actually managing a project, it's the thing that comes to bite you in the ass, right? Which is, managing resources, accounts, projects and stuff. Anything that you all learned, doing this across like the three hyperscalers?
Yeah. We talked a bit about it and the differences with accounts and projects and subscriptions. I mean, we learn some things, but I think these are the pain points continuously. And you forget them all the time. Like you don't interact with them for a while and then you're back at it, right? And I think these are probably the provisioning bits that are trickiest, at least for us. It's like, how do you start with the account provisioning in each cloud? And obviously there's no overlap there.
Yeah, that's super fair. So yeah, we did talk a bit about how like AWS has at least the way that we use it. I think a lot of people do this though, is we use a full account for tenant isolation. And that can be kind of tricky to work with just because, automating the creation of those accounts, kind of setup of them is a little tricky. It's a lot easier in something like GCP. And then, so we've had to kind of come up with ways, right, where like we have these provisioning accounts that can then create an account and then kind of configure that, and they have limited access, but that's still kind of a privileged thing. So that was all a bit tricky to figure out. It becomes also, this is a lot easier in the last few years. So even like, I don't know, 6, 7, I forget when they released this, but a couple of years ago, maybe 10 years ago even, I'm not sure, was before AWS released AWS SSO, which is now called IAM Identity Center. And it was a lot harder to do this, right? You had to kind of do this like STS thing on your own to get temporary tokens for each account and log in and whatever. And so it's gotten a lot better now that they have this identity center thing that will set up SSO for you, and like it will automatically do that thing where it goes into every account and sets up a profile so that you can assume that role in the account and whatever. So it's gotten a lot better, but it's still a bit tricky to manage at scale, and it's tricky to automate the initial setup of those accounts. And it's a bit easier in GCP just because of the IAM bits and stuff that are better, like we talked about. But it's similar where, there's a lot of subtleties in automating like a full setup of one of these things from scratch. Like once you have a project or an account and you have some credentials to log into it, then running infrastructure as code tools and deploying everything is like easy peasy. But setting up that account and those initial credentials, especially like I said, because that's such a kind of privileged operation, is tricky to do in a way that like scales well and is secure, and it's different across every cloud.
Yeah, I can imagine. And I must tell the viewers that we at AuthZed, we have had like close to 5 years of, trying to hone these things. And in a couple of weeks, we're actually celebrating our 5th birthday. Yes, AuthZed is 5. We're doing an infrastructure authorization infrastructure event right here on YouTube. More details about the speakers and the schedule on that link that you see there. We also have speakers from Canva, Turo, and also Carnegie Mellon University. So lots to look forward to, and some announcements coming up there as well. So check it out. Adin, Bison, Brad, I think the one thing that everyone always wants to know when it comes to the hyperscalers is things around cost management and cost optimization, right? You all touched upon earlier how when you're providing cloud infrastructure to customers, things can add up. So again, there are a bunch of learnings along the way. Let's talk about costs, right? And Adin, why don't you start?
Yeah. Could maybe kick off with GCP or GKE. I think it's the Kubernetes provider that kind of offers the most, right? and it was the first one, right? So it has a vast array of toggles, and they provide good value. I mean, and most of them are on by default, but it also means that it costs money, right? You have managed Prometheus, you have logging, you have backups, and it's always unclear how much these things actually cost, because you can enable logging, but it's like what's the logging volume that actually gets sent? Same goes for metrics. How many series are actually uploaded to the managed Prometheus, and the same goes with backups. That kind of does per pod costs. So how many pods are running? How much does that cost? And GKE comes with all of these features, and I think by now most of them are toggled by default, and we detoggled some of them because we have, let's say, we self-manage Prometheus and Grafana and Loki for logs. And I think AWS probably has least of these features out of the box. However, it is growing with EKS Auto Mode. They also have managed services for Prometheus and Grafana, but I don't think they're integrated with EKS yet. You have the concept of add-ons, Core DNS, EBS, CSI. There's community add-ons also for New Relic and Datadog, and that's even more cost. I don't think we've used those or explored those. I think for Azure, it's very similar to GKE, or at least AKS Automatic, which is in preview mode. So it will come with the managed Prometheus and Grafana. It's nothing we use today. As I said before, we self-manage these things. So in terms of cost, as I said before, GKE, vast array of toggles, but every single one of them adds some type of cost. And for us that are building our own cloud, this becomes important, right? And I think also not only in terms of cost, like usability, we kind of want the same UI, like log presentation. Azure's UI looks completely differently, and the query language, right? And the same goes for GCP and AWS. So we use Loki and Grafana, and then we can have the same query UI between all three of them.
Yeah, I can only agree with all of that. Yeah, that's the thing, right? Is that that's a good point, right? That all of the different providers have a lot of this tooling, and then you can toggle it on or off. But like you want it to be the same across providers when you're doing a multi-provider thing. So then you end up kind of turning those things off and doing your own. And that's also that's interesting from a cost perspective, because the managed offerings that they have, some of them are really good, but they're super expensive. So you have to kind of think about that in terms of cost. But then on the other side, there's also a cost to running it all yourself, right? And that's a struggle that we have for sure constantly, is that, we have kind of a target cost for one of these for a single region of a single dedicated deployment in whatever cloud, right? And there's a struggle or a constant kind of push and pull between, well, we want all this cool tooling, but if we're going to actually have to deploy it to each environment, then that's extra cost, right, that eats into that. And so, like, do you spend that budget there or elsewhere, or can you maybe do something that scales differently by centralizing that and shipping stuff elsewhere? But then you also have to think about like where that data lives and how expensive it will be to ship it somewhere, and then how you scale that thing that's central, and that kind of thing. So there's a lot of decisions that go into deciding which of these features to use and which to not, like what to kind of build yourself or what not to. And I also really agree with the point that GKE, I think, has the most complete set of kind of managed features around the Kubernetes offering there. So like, yeah, like you said, backups and logging and monitoring and all of that kind of is included. But yeah, especially, so the logging is like, a lot of that stuff comes from their acquisition of Stackdriver, right? And it's like super, super cool, especially the logging in GKE that's on by default is like, I would love to just like have that everywhere basically, but it's super expensive. I remember definitely we had a situation where I think that we had turned on for some component in SpiceDB, we had like debug logging on by default, and and watching these kind of cost dashboards or whatever, where all of a sudden it's like, well, the logging literally costs more than all of the compute and everything combined, right? So it's definitely something you have to watch out for and set up like billing alerts for and that kind of stuff. But that's another pain point, is that the clouds have cost management tooling and budgeting things and dashboards and whatever, but of course they are also all different between all of them. So you have to kind of go and figure that out for each one. And there are a bunch of cool services that will kind of do some of that for you and try and like do optimization and offer suggestions and whatever. But those things themselves are expensive, right? Because they're usually like a percentage of your cloud bill. And so, right, the thing being that if it shrinks, then so does the price tag. But that it's can be really expensive to get started with.
Yeah.
And
Before that, I mean, comment from B-Day. Our use case was a bit outside the recommended architecture due to the low amount of expected requests. We only use one container behind an LB. Oh, okay, that's cool. And able to deploy our data store, which is Postgres, within the initial migration as a Lambda, still developing a permission system before we fully migrate to SpiceDB. That's awesome. Pretty green team in an industry outside of tech, so I have no claim of doing it perfectly, but the current implementation is pretty performant. Well, that's awesome to hear, BDay38. Thanks for sharing. Brad, Adine, any thoughts on this model perhaps?
That sounds like a fine architecture, right? Like you want to, of course, eventually scale out to have a highly available setup where you have multiple SpiceDB replicas that talk to each other, and then you have to figure out. So if it sounds like you're not running on Kubernetes, so then you have to kind of figure out how to do service discovery between the SpiceDB replicas there, or it can just kind of be manual at first. But that sounds all fine. And yeah, I mean, we do something similar, right? We have a lot of people that run on Postgres, and we do so when we run this on top of Kubernetes, we do migrations as like a job that runs on top of Kubernetes before the actual pods and the deployment start up. But that's not that much different than having it run as a Lambda, right?
Yeah, I was going to say the same thing. Same concept, different platform, just a pre-hook job. Sounds cool.
Totally. Yeah.
Yeah, it's awesome. All right, so towards the end of the stream, I actually want to talk about how we at AuthZed sort of unify all of this, right? And I know we have like an AuthZed binary that does like generates configs and stuff, which makes our lives easier, which I think is like a super smart way of doing it. I'm sure lots of folks out there deal with multi-cloud, and they need to have a way to, automate building infrastructure across the three. So I'd love to, for you all to talk a little bit about that. So yeah, Brad, if you can tell us a bit about it.
Sure. So we have an internal platform for deploying and managing all of this. And like I said at the beginning of the stream, in building our platform for users, Kubernetes and operators are definitely a big part of our secret sauce. And so I don't know, I was in that mindset when thinking about how to start building out the internal platforms. And so it's similar. A lot of parts of our internal platform look like the kind of user-facing platform, but just at a different kind of layer of the infrastructure. So we have API, so Kubernetes CRD definitions basically that described our different kind of stacks. So for dedicated, right, we have a CRD called a dedicated stack, and it has information about like which account this belongs to and which provider this runs on, and then config for infrastructure as code to tweak any parts of that, like the cloud specific parts of the platform, and then kind of like configuration for different software components. And we have we have management infrastructure clusters where those kind of configs live, and we have internal operator that can react to changes on those. So, okay, a new dedicated stack has been created. I need to go and do X, Y, and Z to set that up. And it kind of gives us an API then for where we can abstract different parts of the different configurations across the different clouds. So we can have all of our common stuff that says, again, like this is what this stack is called and what account it belongs to and whatever. And then we can have like embedded bits that are different maybe between each cloud provider that get passed on to the infrastructure as code for that. And then we have like an internal API based on that to be able to query information about which stacks exist and where they are and what their state is. And so we feed that stuff into Pulumi. We use Pulumi for infrastructure as code. And then that thing, Pulumi, goes and creates a Pulumi stack from that and spits out some cloud infrastructure. So we try and keep that part pretty small because I think anybody that's tried to manage a bunch of individual stacks with infrastructure as code, Pulumi or Terraform or whatever at scale knows that it's a bit of a pain, right? There's always cases where like something changed and it wants to recreate this, or the state got out of sync and now I have to re-import this or whatever. So we try and keep the footprint there very small. We're very happy with Pulumi, like, and we use Pulumi Enterprise in their cloud offering, and it's we're happy with it, but still, just because of that, we try and keep the footprint pretty small. Anyway, that thing goes out and creates cloud infrastructure. It creates an account or whatever. It creates a VPC network. It spins up the Kubernetes cluster. And then what we have is, based on that, we have a set of like kind of typed outputs for a stack. And so all those cloud resources, Pulumi goes and finds information about them, like this is the ID of the VPC that was created, or this is the whatever the URL for some S3 bucket, that kind of stuff. And it records it in this API for typed outputs. And we can use that as input for our kind of configuration system, which is based on JSONet and Tonka. Tonka is a Grafana project that uses JSONet to generate Kubernetes configurations. So we can feed these like typed, we have an API that, we know that we'll have this information about the stacks across the different providers. And we can feed that as input to this layer that goes and generates on-cluster configs for the Kubernetes clusters. And that's a big part of how we kind of manage the differences between the providers, right? Because we know that we have these typed inputs that describe the cloud infrastructure for each provider. And then it feeds into the system where we generate the configs, and they like mostly look the same across the 3 different providers, but they then, when it's necessary, they can say, is this AWS, then do this thing. Is this GCP, do this thing. And we can build abstractions on top of that that say like, so one thing that's common, right, is that you have a service account that lives inside Kubernetes, and it has some annotation that links it to an IAM identity in the cloud provider. And that lets whatever using the service account inside Kubernetes talk to S3 or something like that. And so inside this kind of config generation system that we have, we can just say, give me a service account called this in this namespace. And then the like code behind that can go and say, okay, this is a service account definition, but also which cloud am I on? And did I find an IAM role that's linked to this? And if so, then add the right annotation for whatever cloud provider. That's one example, but we can use this kind of like well siloed set of steps for defining the infrastructure to then abstract over these kind of details across the different providers that differ, right?
Yeah, that's a super smart way to actually manage this. And Nadine, you have also worked on this, right?
Yeah, I would say this is more of Brad's baby, and he's put a lot more time into this. But I would say the big value proposition, we talked earlier about K8s and how it kind of mimics setups between the 3 clouds. But for everything that isn't K8s, we kind of need abstraction. And this is what our internal API does. So all of the other services, subnets, VPCs, load balancers, other networking components, security groups, etc. We use the same API, even though the implementation differs, but the configuration references are fairly similar.
Yeah,
that's awesome.
And that's like so you mentioned at the beginning, right, that we do have like internal tooling, like our internal CLI that we can interact with these stacks. And that's also a part of this, right, is that being able to build in a really similar way, like I said, that we do for our user-facing platform, for our internal platform, being able to build like on top of all of the tooling that we have for building operators and APIs on top of Kubernetes. Being able to do that for our internal stuff is cool, because then we can easily build this tooling so that we can have a CLI or a dashboard or something that like in real time gets information update about like what's happening, or which stacks exist and where they are and how do you connect to them and that kind of stuff.
Very cool. Nice. I think, anyone who sort of works in like the platform IDP DevOps space and works with multi-cloud, would love to hear from this. There's another comment from BDay38, which I will read out, which says, thanks for the input. We plan to pivot to Kubernetes if necessary. SST has limited Kubernetes support, so when trying to deploy with Pulumi through an EKS, We ran into problems, just needed an MVP. Yeah, well, if it works, it works. And you did mention it was also performance, so that's absolutely fine. And also, BDA38, feel free to jump into our Discord if you have any questions about this. All of us hang out there, so if you have any questions, or you can write to us as well. So, but so happy to hear that, it's working as is. Yeah.
Yeah.
Cool. I think we have covered anything else we may have missed that you might want to just quickly shout out, Brad, Adin? Yeah,
I think we're good. For our first session, we're good.
Yeah,
I think we covered a lot of ground, so yeah, all
yes,
good.
nice. Yeah, and also, folks, just want to shout out two things before we leave. One is, yes, AuthZed is turning 5. The little baby is now almost 5 years old, and in 2 weeks we have an authorization infrastructure event. Make sure you register on that link. If you register, you also get free swag. We all love swag, but also there are some great talks by folks from Canva, Turo, Carnegie Mellon University, and of course from AuthZed. So check that out. And we have a bunch of streams coming up this entire month as well. So next week, I'll be talking to Veronica about Terraform infrastructure as code and how we built our Terraform provider to do some of the things that you might have heard of today. Anyway, Brad, Adin, thanks so much for having us. And for folks watching, Jimmy, Akash, BDA38, thanks again. And we'll see you next week. Bye.
Thank you. Bye-bye.
Thanks. Bye.